So in the first video, we talked about rational functions and the three weird things that can occur in rational functions. We said that holes can appear in their graphs, vertical asymptotes might occur such that our graph can't cross these vertical lines, invisible vertical lines. Horizontal asymptotes may occur, horizontal invisible lines that our graph cannot cross. But for this video, we're just going to be focusing on the holes. So the big question is, how do we know when holes occur in rational functions? Well, holes will occur when terms end up canceling out from the numerator and denominator. So I got two examples here for us. Let's just work through them, okay? So here's my first example. Here's our rational function right here. I have x squared plus x minus 6 divided by x minus 2. Now I know this is a rational function because I have x's in the numerator and I got x's in the denominator as well. Okay, so our goal is whenever we try to find holes is to simplify first our equation and then we'll see if things cancel out. So let's look at the numerator. We know just by looking at it or with some little analysis that we can factor this guy. All right, x squared plus x minus 6. Well, we can factor him into x plus 3 times x minus 2. Now look what happens here. We have an x minus 2 in the numerator and we have an x minus 2 in the denominator. So if we have the same terms on top and bottom, guess what happens to them? They end up canceling out. We just cross them out. Okay, so that means this whole complicated looking rational function, after simplifying, just looks like this, x plus 3. So what does that mean for us? That means this complicated rational function over here, what does it look like if we were to graph it? That means it will look like this guy, x plus 3. It will be the graph of a line. It will be a line with slope 1 and a y-intercept of 3. Okay, so it's just a line with slope 1 and y-intercept 3. But we said if terms cancel out, that there's a hole somewhere. So how do we find out where the hole is? Well, what we're going to do is we're going to set that cancel term out. For us in this question, it's x minus 2, and we're going to set it equal to 0. So to know the location of the hole, we're going to set our cancel term equal to 0. So here I have x minus 2, which was our cancel term, and I'm going to set it equal to 0. And I'll solve for x. So I found out that x equals 2. This x equals 2 right here, this is the x-coordinate of our hole. Okay, so this is the x-coordinate of the hole in our graph. So we have the x-coordinate, but every point on our curve has two coordinates, an x-coordinate and a y-coordinate. So now our goal is to find the y-coordinate. We can find the y-coordinate of the hole by plugging our x-coordinate that we just found, here it's 2, into your simplified equation. So do not plug it into this guy right here. Don't plug it in here. What's going to happen is you're going to get zeros in your denominator. Plug it in to this guy, your simplified version, which here for us is x plus 3. So that's the biggest mistake students make. Plug your x-coordinate into your simplified equation. So we're going to plug 2 into x plus 3, and we'll find out that the y-coordinate of the hole, so the y-coordinate of the hole is 5. This means the hole is located at let's see, x was 2, y was 5. Okay, so this complicated rational function, which was x squared plus x minus 6 divided by x minus 2, once we simplify, that it just has what it looks like when we graph it is just a line with slope 1 and y-intercept of 3, but it has a hole at 0.25. Okay, so let's go ahead and let's look at that on Desmos. So here's the function that we were just graphing, x squared plus x minus 6 divided by x minus 2, and we're going to go ahead and graph it. Hey, and look what that is. This is a line. Let's see. Can I find the y-intercept? Y-intercept of 3. Right? Y-intercept of 3. And it has a slope of 1. It's hard to tell just from this. But what I want you guys to focus on here is that let's go to 0.25, all right? Let's go to 0.25 where we said the hole was. So here's x equals 0. Jesus Christ. Come on, work for me here. There it is. So here's x equals 1.5, x equals, we're going all the way to x equals 2. And if I can hone in on it, what does it say? At x equals 2, our graph is undefined, all right? So this makes sense because there's a hole right there at x equals 2, right? So this point right here is 0.2, 5, but the value of that function when x equals 2 is undefined because there's a hole there, okay? Good. So let's just do another example. Boom. Coming back over here. All right, so we got example number 2. Here's our second rational function. So we have x squared minus 4 divided by 2x plus 2. We know this is a rational function because there are x's in the numerator and x's in the denominator. I keep saying that because you might get something like this. You might get something like 2x plus 1 divided by 2. Now, yes, this may look like a rational function because there's a fraction going on, but if we really just separate this, we can write 2x plus 1, this guy divided by this guy divided by 2. See, I split up my fractions here. And if we simplify this further, we find out that the two 2's cancel out, so I'm left with x, and this guy is just plus 1/2. So if you don't really have an x in the denominator, I mean, there's no need to consider it a rational function. It's more work than necessary because we found out something like this can just be a line with slope 1 with y-intercept of 1/2. Okay, anyway, so here's our second example. 4x squared minus 4 divided by 2x plus 2. And there goes my cat. So one thing I want you guys to notice is that when we simplify it, it's all about factoring. So what can we factor out first from the numerator? Well, I can pull out this 4. All right, I'm factoring out this 4, and in the bottom, I'm going to factor out this 2. So on the outside of these parentheses, we have 4 divided by 2. And 4 divided by 2 is just 2, okay? But let's see what else can factor. I hope you guys remember from our previous lecture that if you ever get something like this, x squared minus something squared, we can use the difference of squares formula of squares. So pretty much, well, you guys are in front of a computer. If you don't know what that is, Google it. Difference of squares, it'll pop up real quick, and it'll be really easy for you to figure out what's the next step looks like. So I'm going to factor this guy out using the difference of squares property. So remember, 4 divided by 2 is 2. And using the difference of squares, I get x plus 1 times x minus 1 also in the numerator. And look what's left in the denominator, x plus 1. So guess what? This x plus 1 and this x plus 1 cancel out. Boom. All right, these guys, they're just gone. All right, they canceled each other out. So what am I left with? I'm just left with 2 times x minus 1. And we can simplify that as 2x minus 2. So this whole complicated rational function right here, we can just simplify that as 2x minus 2. So this rational function, what does it look like? Well, it's a line with slope 2, right? And a y-intercept of minus or negative 2. So slope 2 and a y-intercept of negative 2. And I go ahead and express that right here. So this graph is a line with slope 2 and a y-intercept of minus 2. But we said because terms ended up canceling out, that there's a hole somewhere. And we already said in the previous step, how do we find the hole? Well, we set up the cancel term. Here it was x plus 1, and we set it equal to 0. Solve for x. X equals minus 1. This gives us the x coordinate of our hole. To find the y coordinate, plug this guy into the simplified version. So this guy right here, simplified version of our equation. So I put minus 1 into our simplified version of our equation to find the y coordinate of the hole. This tells us that the hole is located at point minus 1, minus 4. Okay, so let's go ahead and let's look at decimals one last time. If I could pull it up right here. Okay, so right here we have 4x squared minus 4 divided by 2x plus 2. I'm going to go ahead and graph it. And here's the line that we said would occur. It should have a y-intercept of minus 2, just like what we said. And the other thing we said was that there's a hole at minus 1, minus 4. So let's go to minus 1, minus 4. What do we get? So we're going towards minus 1. X equals minus 1, x equals minus 1, x equals minus 1. And what are we hoping to see at x equals minus 1? Yup, there's a hole, right? If I can hone in on it, right there. At x equals minus 1, our function is undefined because there's a hole. All right. So I hope this video helped you understand a little bit about holes and rational functions. I'll see you guys in the next video.